Hello dear students, let us try to calculate other numericals based on colligative property. This numerical is from page 57, question 2.1. Vapor pressure of pure water at 298 Kelvin is 23.8 mmHg. 50 gram of urea is dissolved in 850 gram of water. Calculate the vapor pressure of water for this solution and its relative lowering. Relative lowering, it is talking about relative lowering in vapor pressure. So we will be using the formula for relative lowering in vapor pressure. Firstly, what we will do is we will write down all the values mentioned in the question. So vapor pressure of pure water is already given as 23.8 mmHg. Mass of water is also mentioned 850 gram. Mass of urea is also mentioned 50 gram. Now our next motive is to find out the molecular mass of water and molecular mass of urea. We already know very well how to calculate the molecular mass. So molecular mass of water we got as 18 and molecular mass of urea we got as 60. Now we will write down the formula for relative lowering in vapor pressure because the question is clearly mentioning that it is relative lowering in vapor pressure numerical. So we know this formula, relative lowering of vapor pressure is equal to the mole fraction. Mole fraction, further after classification we will get this. I have already explained, so I will not go in detail. So what we have to find out is, first we have to find out the relative lowering in vapor pressure, as well as we have to find out the vapor pressure of water for this solution. Here let us now write down all the values given. PA naught is given as 23.8, PS we don't know, PA naught again 23.8 equal to W2, that means mass of urea is already given as 50, molecular mass of water, then molecular mass of urea M2 and mass of water already given as 850. Now, upon calculation, don't get confused that this is a relative lowering of vapor pressure and this is the mole fraction. So here, after multiplication, we'll get 51000. So here our first motive is to find the relative lowering of vapor pressure. This whole value, it is a relative lowering of vapor pressure. So upon calculation, upon division, we will get 0.017. We know that this is a relative lowering of vapor pressure and we got the value for relative lowering of vapor pressure as 0.017. For now, ignore all these calculations. Just know that this is the relative lowering of vapor pressure. And for relative lowering of vapor pressure, we got the value as 0.17. So this is your relative lowering value. Now our first task is done. We have to find out the relative lowering of the solution which we already found out. Now we have to find the vapor pressure of water in the solution. Now we already got this value. So upon cross multiplication we can easily find this value as well. So 23.8 minus PS is equal to, upon cross multiplication, 0.017 into 23.8 minus PS equal to this will also become here minus according to Bodmer's rule. First we will do the multiplication. So upon doing the multiplication we will get minus 23.8. If we do subtraction, since this is a larger value, the answer will come in minus. Plus and minus will be minus, subtraction will be done here, but sign will be taken as minus since this is a greater value as compared to this. So after subtraction we will get 23.3954. So minus minus gets cancelled. So vapor pressure of water for the solution we finally got as 23.3954 mmHg. We also found the relative lowering, and now we also got the vapor pressure of this solution. So our final task is also done. So this is how you will calculate numericals based on relative lowering of vapor pressure. Now let us do the next numerical. Boiling point of water at 750 mmHg is 99.63 degrees Celsius. How much sucrose is to be added to 500 gram of water such that it boils at 100 degrees Celsius? Now, in such type of question, you have to be very cautious about every word. In this question, boiling point is mentioned. That means it belongs to the elevation of boiling point colligative property. If freezing point was mentioned, it will be depression in freezing point. But in this numerical, we'll be doing the calculation for elevation of boiling point. Now, what is this question asking us to find out? How much sucrose is to be added? That means it is asking us to find the number of moles or mass of the sucrose. And we also have to know the formula of any component mentioned in the question. In this case, sucrose, the chemical formula is C12H22O11. So upon calculation, we will be able to find out the molecular mass. So now let us write down whatever it is mentioned in the question. Mass of water. Since water is a solvent, it is denoted as Wa, which is given as 500 gram. Now molecular mass already we have found out, that is 342. And if you remember, Kb for water is 0.52. It is a fixed value. Also, the boiling point of pure water, that means boiling point of pure solvent, Tb0 is already given. Boiling point of water is 99.63 degrees Celsius. So Tb0 we already have. Now, since we have to find out the number of moles or mass, we have to use the formula, the complex formula. So in this formula, we already have the values for almost all the parameters. We have to find out Wb, but we don't have del Tb. So del Tb we have to calculate. Del Tb is given as the boiling point of the solution minus boiling point of the pure solvent. Boiling point of the solution. Now the question arises that what is the boiling point of the solution? Here, how much sucrose is to be added in water? That means solute is being added up in the solvent. So solute plus solvent will be solution. So here it is already mentioned it is 100 degrees Celsius. So Tb is 100. Even in many cases, even if it is not mentioned, just assume it to be 100 because 100 is the normal boiling point of any liquid. So Tb 100 minus Tb0 is 99.63. So from here, upon calculation, we'll get 0.37 degrees Celsius. Now we will put all the values in the formula. Mb, that means the molecular mass of sucrose, is 342. Kb we already know it is 0.52. Wb we have to find this out. So Wb will remain as it is. Into 1000 comes from the formula. Del Tb we just found it 0.37 into Wa. Wa mass of the water is already given as 500. So upon cross multiplication, 342 into 0.37 into 500. So Wb we can write this as divided by 0.52 into 1000. So WB becomes, upon calculation, upon multiplication, 520. These two multiplied, we will get this number. So upon division, we will get 121.7 gram. So the question asked us how much sucrose is to be added. So we got the answer as 121.7 gram. Let us do the calculation for next numerical. Calculate the mass of ascorbic acid vitamin C C6H8O6 to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. Kf value is mentioned, that is 3.9 kg mole inverse. If Kf value is not mentioned, remember that Kf value for water is 1.86. Now in this case, you can see here that lower its melting point by 1.5 degree Celsius. So this means that lowering of melting point del Tf is 1.5 K. It is already mentioned in the question. Kf value is also given. Wa, in this case acetic acid is the solvent, so Wa, that means mass of the solvent, is given as 75 gram. Molecular mass of vitamin C is already calculated, which is 176. So Mb is 176. Del Tf already given. So as I said earlier, from the question itself we will know which colligative property to use. From Kf itself you will know that we have to use the depression in freezing point colligative property. Even from melting point, if melting point is there, that means it is depression in freezing point. If boiling point, that means alleviation of boiling point. So we know the formula for depression in freezing point. We have to calculate the mass of ascorbic acid. Same as the previous question, we have to find the mass of ascorbic acid. So here del Tf is given as 1.5 is equal to Kf value is also mentioned, which is 3.9 K into Wb. We have to find out 1000 from the formula. Mb we already have 176 into Wa we already have 75. So again upon cross multiplication we will get 3.9 into Wb into 1000. So directly upon cross multiplication we can write, okay, let me do the step. 3.9 into Wb into 1000 equal to 1.5 into 176 into 75. So from here upon calculation we will get 3900 into Wb, and here 1.5 into 13200. So Wb can be written as, upon multiplication we will get 19800 divided by 3900. So upon division we will get our final answer as 5.08 gram, which is an approximate value. So here we were asked to find the mass of ascorbic acid, which is Wb. So we found out Wb by using the formula, which is depression in freezing point. How did we come to know that this is depression in freezing point numerical? Because Kf is mentioned, and also melting point is also mentioned in the question. So we concluded that we have to do this calculation for depression in freezing point. Let us try to solve this numerical. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer of molecular mass 185.30 in 450 ml of water. Here we know that already the molecular mass is mentioned of the solute 185.30, and mass is also mentioned, that is WB 1 gram. Volume is mentioned, which is 450 ml. Temperature is also mentioned, 35 degrees Celsius. In the question clearly it is mentioned calculate the osmotic pressure. So directly we will put the osmotic pressure formula. Before that, temperature. Since Pascal is mentioned, temperature should be in Kelvin. So we know that in order to convert Celsius to Kelvin, we add 273. So we get 310 Kelvin. Now we also know that osmotic pressure formula, which is pi is equal to WB into RT divided by MB into volume in liters. Now we know that WB already given as 1. Now R, gas constant. Previously we used gas constant value as 0.83. We used 0.83 because the pressure unit was mentioned as bar, but here it is Pascal. So we will be using 8.314 into 10 to the power 3. So 8.314 into 10 to the power 3. Temperature we already calculated as 310. MB, molecular mass, is also given as already given. And volume, it is saying that it should be mentioned in liters, but it is mentioned in ml. So in order to convert ml to liter, we will divide it by 1000. So upon calculation, 1 into, let's write it once again. If this reciprocate, 1000 will go in the numerator, divided by 185, 450. So it becomes, upon calculation, 2577.34 into 10 to the power 3. Upon multiplication, you will get this value, 185,000 into 450. So here, upon multiplication, what you will get is divided by 83250 upon multiplication. So when you divide it, you'll get into 10 to the power 3. You can leave it as it is, or if you want to bring the decimal point ahead, then you can also do that. It can also be written as 30.9 into 10 to the power 3. Since we are moving 3 steps ahead, 1, 2, 3, so it will be minus 3 Pascal. So this can be written as Pascal. So this one, approximately, this can be also written as 31 Pascal. So this is how you will do all your numericals. But always remember, practice will make you perfect.